This is page 2 of our review notebook, and up in the corner again, just to remind me, I'm going to put ps2. Remind me that this has to do with the standard of learning physical science 2. And these are other ways to classify matter. We can use properties in order to identify and classify matter. And there's two main types of properties. You have physical properties and chemical properties. So we'll put physical on this side, and we'll put chemical on this side. Okay, the physical properties are the things that can physically be done to an object without actually changing its chemical composition. So some of the physical properties we have are going to be shape, we have density, solubility. Remember, solubility is the ability to dissolve. We have odor, melting point, any of the phase changes. Boiling point, because even though I have water, when I turn it into water vapor, it's still going to be H2O. I haven't changed its chemical formula any. Color and freezing point. And then the chemical properties, we have things like acidity, basicity, if I can spell tonight, combustibility, and I just cannot spell tonight. Okay, combustibility, that's like flammability, will it catch on fire? I didn't have room on your screen, but that is, here's the rest of it, and reactivity. Okay, so there's your two types of properties. You have physical, and then you have chemical. All right, we're now to about the middle of your page, or maybe the first quarter. We're going to get to the middle of the page, and we're going to talk about pH. So I'm going to clear, and at the very middle of my page, so right here is the middle of your page, I'm going to create a pH scale. Now, remember the pH stands for percentage hydrogen, and so a litmus paper is going to measure how much hydrogen ions it detects in the solution. And the more hydrogen ions it has, the more acidic it's going to be. So I like to write my pH scale as from the 0 point to the middle point is going to be your acids. Remember, 0 is the strongest acid you can get, and then 7 is neutral. And then I like to do blue because blue is what it turns litmus paper. That's going to be your base. Highest you can go is 14. And that's the strongest base that you can get. Now, things that we like to remember about each one is an example of something that's neutral. Is going to be a salt. When I combine acids and bases in equal amounts and concentrations, I'm going to neutralize. They're going to start to neutralize each other until you get to a salt. Another example of something that's neutral is water, bottled water, well water, maybe not town water. That's going to be kind of slightly basic because it has chlorine added to it. So then we're going to talk about qualities or examples or descriptions of each. So bases create hydroxide ions, hydrogen, oxygen, hydroxide. ions. And so we're going to put hydroxide under here just to remind you what OH stands for. Okay, and if you see that in a chemical formula, you know you've got a base. And things to remember about bases is that they are slippery, is that they turn litmus blue. BBB, bases, blue, bitter. So they are bitter. And they're non-reactive. They don't really react with anything. Okay, and then you have acids, the opposites of bases, and they create H+ ions, which are hydrogen ions. So we're on hydrogen. And there are several characteristics of acids. They are corrosive, and the stronger it is, the more corrosive it is. They turn litmus red. Remember, litmus is an indicator type paper that helps you to indicate whether something is an acid or a base. And there are natural litmuses, or natural indicators, like red cabbage juice and hydrangea bushes. Acids are sour and they're reactive. Okay? So down at the very bottom, just a reminder, a little study tip in here that you may want to use while you are studying is that SOL pass, we'll just stick this in here, www.solpass.org, has a great practice site on pH. Okay, so at the very bottom here, we just want to do one more thing that has to do with matter, and that has to do with density. And you need to make sure that you can solve density problems and know that the formula for density equals mass over volume. And the way we like to say it is dense people get broken hearts. So I'm going to draw my little heart here. I'm going to break it, and you're going to see that the top part of the heart is an M for mass, and the bottom part of the heart is a V for volume. And that's your formula for density. And what that means is if I've got two blocks that are exactly the same volume, so if you make it exactly the same volume, so they're exactly the same size, the block that has more particles per volume is going to be more dense or denser than the block that has a few particles. Okay, and that's all for page 2.